Okay, so what happened to the frame after welding? Nothing. I mean, that bolted down tight. Mucho bueno. So what I don't like about this frame is the bottom gantry is 2040, but two 2040s butt up against one another. And the top and the bottom is welded. You can see it there on the bottom. And these uprights are also welded here and here. Okay, these also. And with the type of Z system that I use, the rails are going to go in the front here. Okay, here's the pulley for the belt. These rails here are really not important on alignment. The bed is going to float basically on the carriage blocks here, so the bed can do what it wants because it's all controlled by the back end. So really what's critical here is that this back 2100 is on plane with the with these frame extrusions here in the back. So when it goes up and down, you don't want it to skew left or right, and then also you don't want it to skew front to back. I assembled this with 1, 2, 3 blocks in a precision square. I did not go back with the indicator and tweak it in and then weld it. So I imagine there might be something here. I'm not sure. We're going to find that out. But I should be able to square it up. So it you know, I put this on, put the gantry on this morning to test this direction, well, X direction anyway. I already had it for the Y direction, and it flows just as well that way. What I don't like about this is 4040, and these are cheap extrusions. The main thing is that they're hollow, and these bolts here are going to be used to hold down the halo. And if you bolt this down tight, what's going to happen is that 4040 is going to compress here, and it can't be solidly bolted. It's going to flex, and it's going to be in tension, and as heat goes in that frame, it's going to vary the force here because that frame's going to try to expand upwards. I don't like it. If this was filled with epoxy, that would be fantastic. What I may end up doing, I might end up just filling these two outside ones, or what I might do is put standoffs on the inside here, so when I bolt these bolts down, it's forming a solid connection and not something that's going to be springy or deform or crush this corner. I really do not like these. I'm not a frame builder. I should have looked through the catalog and looked at some better extrusions that were more supported on the inside here. But I think a 2040 is stronger than this 4040. That's my opinion anyway. Just because this is much more solid than this one is. So anyway, these are my belted Z mounts. I've got them here, and these have they have bolts going up. They have bolts going up here into the top, another one that goes up into the top, and then one that goes over into the side. So this is kind of tricky to assemble. You have to put in the two bolts facing up first, and then you have to insert this side bolt and then slide the T-nut up there, or use a spring nut to hold those. That way I've got it compressed up, and I've got it compressed to the side to stop it from doing this. So I'm just kind of getting some parts together to kind of mock this up. I still may work on the frame some more. I'm thinking about adding some braces on the side here. It just happens that I'm going to use a lot of the parts from my other printer for this printer, and I've already got panels made. This frame is the exact width of my other frame, and so the panels fit, except they're too short. So I may add that brace across the side there, and then I can fully use the panel that I already have, and then I'll just need one panel to go there. I'm not 100% sure how I'm going to do that yet, but I want to reuse as many parts as I can from the old Sapphire frame or the existing system that I have, just to save on cost. And I've already got the plates cut and holes drilled in them and all that sort of stuff, so I'm just going to try to reuse what I can, because I'm pretty sure that other printer is going to, whatever leftover parts are going to go with the rest of the robots in the drawer, I call them, like in iRobot, when all those robots are in the Connex out in the back field. I've got my own Connex of printer stuff. So but anyway, this will have the 1PZ system with the universal joint in it, like in my current printer. And I'm not sure what I'm going to do with the bottom of it. You know, the bottom of it's got these long legs here. I'm thinking about even making a filament dryer in the bottom of the printer. The electronics, I thought perhaps I would put them vertical down here. I could have one panel for the power supply, another panel for the MCU and the Pi. So, you know, maybe in the back have the power supply, on the side I could have, or the front, I could have the you know, the Octopus or the MCU, and then maybe there'll be room for filament spools, or maybe I just need to make a remote enclosure for the power supply, like a backpack, and then just use Amphenol connectors for all the wires, and just have one bulkhead connector in the back or whatever, and you just plug the backpack in. And then if you make any future printers, you could use that same backpack to just switch it over. But anyway, so this is looking really good here in terms of flatness and alignment. I'm pretty shocked, actually, how well it kind of worked out. But I didn't just put this together and weld it. I mean, I sort of did, but you know, I aligned it first, and then I would weld the top right here in this one spot, and then I'd come over to this one and I'd weld this one, and then I'd weld this one, and then I'd weld this one, and then I'd come back and I'd weld the other side, you know, and then I just kind of worked myself around. And that was my first test with it on the granite slab, was to weld this up. And when I was done, I put these rails on and saw how free they moved, and I was like, well, it's still working pretty good. So let's assemble some more and see when it goes to crap, if it goes to crap or not. So, but there's a halo going to go on this. This flatness is important. It's nice to have a base that's very flat, and I think this is going to work out pretty good. The more I think about it, the more I really want to put a steel halo on top of here. But I have my existing halo that's I don't know, 6-7 millimeter thick, and I'm probably going to try to put that on top, but it's really not ideal with the heat. It really needs to be steel. So, well, we'll see. We'll see. It just depends. As I go along, I scope creep in my own head, and all of a sudden other things get added. So anyway, so far, she's looking pretty good.